Hi class. Today we're talking about page 10 from the homework set and problem set. As with all of these problems, you should try to do them on your own before coming to the help that I'm offering here. And I don't give the full answer to the problems in this uh, help, but what I'm trying to do here is to give you enough information that you can actually solve the problem on your own. Um, so I'm not going to address all the problems either. I want to try to do this in a short amount of time, maybe 5 minutes, instead of going on and on. In this first problem, you are told that the plane is at a certain height, and I think it's 27,000 feet, if I'm not mistaken, and he has to descend at 1,500 feet per minute. Eventually, he's going to make it to the ground, and what you're asked to find is the time. If I were to graph it, I'd be looking at feet per minute being the slope, something in feet per minute. If you can find the slope, you start at your y-intercept, which would be the starting point, until you reach the x-intercept. That's where the y value is equal to 0. So when you write your equation, keep those things in mind. Problem number 3 deals with a very similar setup, except instead of having time on the x-axis, you're going to have a distance. We're going from Lincoln to Des Moines, a certain height in the air. This distance in the ground is 160 miles. And you're asked to find how far it is from Des Moines to the point where he reaches the ground if he keeps going at the same constant rate of descent. And notice that the slope is a constant rate, the rise over the run, rise over the run. In fact, these are two similar triangles. If you were to write a proportion, which is an equation of two ratios, you should be able to do so and relatively easily solve for the distance from Des Moines to the city where he lands. Question 4, we go back to Blair and this dream. Blair is at a certain point and coordinate at 4 a.m. and a certain coordinate at 6 a.m. You could probably find out where she is at 8 a.m. by just looking at how far apart she's going each time. What you're asked to do is to look at this equation, this set of parametric equations. I'd advise you just put x sub naught and y sub naught, that's x at time 0 and y at time 0, right here. So at 4 a.m., make that your time 0. So the x would be 2 and the y would be 5. Also remember that each time interval is 2 hours. So in the first time interval, when time interval is 1, that's a 2-hour part. So the first one time interval, how far did she go in the x direction? That's going to be your rate in the x direction. And how far did she go in the y direction? That's your change in the y direction. Question is, what do you set t equal to get to 8:15? If you're going from 4 to 6, that's one time interval. From 6 to 8 is one time interval. What about so that's 2 time intervals total from time 0. What about to get to 8:15? Think about it. In problem 5, you're asked to show that these 3 points are collinear. I suppose you could do it graphically. I'm really looking for something more algebraic. Perhaps you write the equation of the line and determine whether the points lie on the line. Maybe you use slope. Maybe you come up with some other way, but be creative. Come up with a means of explaining why these are all collinear or if they are all collinear. Question 6 is one you can do on your own. Question 7 deals with trying to see if these points are a square. I take it you all can plot points. At a minimum, you should be able to plot the points. What do you know about a square? What are the properties of a square? How do you show that two lines intersect at right angles or that they're perpendicular? What do you know about slopes of perpendicular lines? Well, find the slope of this line. Find the slope of this line. Show me that they're perpendicular. What do you know about squares? You know that all sides are the same length. How long is this side? You could use the distance formula, or you could make it into a right triangle and use the Pythagorean theorem. But you have to do that for all 4 sides. In question 8, as a means of explanation, I'll show you that the converse. If you have a statement, if A, then B, the converse would be if B, then A. So if linear pairs are supplementary, or if you have a linear pair, then the angles are supplementary. Well, the converse would be if you have angles that are supplementary, then they're a linear pair. And the question is, are they true or are they not? You have to rewrite the statements in this form. Question 10 is a bit confusing. I'm going to get you started, and I'd like you to try to take it all the way to the end with my help getting you started. You have a right triangle, a squared plus b squared is c squared. One of the legs is 12. So this is the formula. And you're supposed to rewrite it. The hint says to say that to set it equal to 12 squared is equal to c squared minus b squared, and this could be factored. Well, I'm going to do the factoring for you with this online hint. Here's the way that this would factor. If you multiply this out, you get c squared minus b squared. And the c times b minus c times b, that goes away. This is called the difference of squares, by the way. So that's the way you would factor this. So here you have these two factors multiply to give you 144. Well, what are all the factors of 144? I started listing them for you. You should list all the factors. And if the larger one is going to be c plus b would be 144 in this first case. The smaller one, c minus b, is equal to 1. You have to solve for c and for b. Well, that means if I add these two equations, I get 2c is equal to 145. So c is going to be 72.5, but that's not an integer. And you're told that the answers have to be integers. So do this for all the factors. Find all of the factors, the c and the b value that would make it up for all, make up all the factors. And I wish you good luck and success.